Welcome to solverfy.
So we're given this matrix A, which is the 2 by 2 matrix with entries 1, 1, 0, 1. So let's compute A square, which of course is A times A, so 1, 1, 0, 1 times 1, 1, 0, 1. And if we compute the product, we get 1, 2, 0, 1. All right, so let's compute A cubed, which can be written as A squared times A. So this is 1, 2, 0, 1 that multiplies 1, 1, 0, 1. We do the product and we get 1, 3, 0, 1. So we suspect that A to the n is equal to 1 n 0, 1. So we show this by induction. So if n is equal to 1, then it's done already, because A to the first power just A, and it is in fact 1, 1, 0, 1. So the top right is 1. Now let's assume this formula true up to some n greater or equal than 1. And we want to show that it's also true for the following n. So A to the power of n plus 1, we want to show that this is 1 n plus 1, 0, 1. So to do so, we write A to the n plus 1 power as A to the n times A. Now here, we use the inductive step because we assume that all the way up to n, the formula holds. So A to the n is 1 n 0, 1. A is 1, 1, 0, 1. Now we do the product. So top left, we just get 1. Top right, we get 1 plus n. Bottom left, we get 0, and bottom right, we get 1. But this is exactly what we wanted to see. A to the power of n plus 1 is indeed 1, n plus 1, 0, 1. This finishes the proof, and therefore A to the power of n is 1 n 0, 1.